Hey everyone, welcome to 5.2 Notes. We're going to be talking about some exponent rules today. Just a reminder that an exponent is the number of times a base is multiplied by itself. The base is the regular sized number, or regular sized number slash letter, I guess I should say. And it can either be a number, a variable, or both. So, for example, over here we have an example of both 3 and a, the regular size ones, that is the base. The exponent is the 4, and that means that you're going to take 3a times itself 4 times, like this. Okay, and this doesn't mean that there are 4 3a's, simply it means there's 4 of them being multiplied instead of being added, so don't get those two confused. If I wanted to simplify this, I could actually multiply 3 times 3 times 3 times 3 instead of leaving all of those out there. And this is called expanded form because we expanded it out and we rewrote it all the way out. The whole reason why exponents exist, though, is to avoid having to do this. Over here on the right side, 5x squared is our base, and 3 is our exponent. So we're going to have 5x squared times 5x squared times 5x squared. Technically, though, if we wanted to write the most expanded version, each time we wrote x squared, we would actually just write it as x times x. Okay, so these are the same thing. And then I would do that 3 times. Okay, so that's expanded form. And the main reason why I'm talking about that is because we will use it to help us understand what exponents are. So the whole reason they exist is to help us save space and some time because it takes a long time to write it all down. So what we're going to do is use exponents to rewrite these examples in a shorter way. So over here, for instance, you have a bunch of 2's. Let's count how many. There are 3 of them, so that would be 2 to the third power. And then over here we have some x's, and there are 1, 2, 3, 4, 5 of them. So that would be x to the power of 5. And then over here on the right, we have 1, 2, 3, 4, 5's. So that would be 5 to the power of 4. Then we have 2b's, so that would be b squared. And we have 4c's, so that would be c to the 4th. This is really just trying to understand what in the world we're doing with exponents. And lastly, over here, there's 2 ways of writing this one. This 3y is happening 1, 2, 3, 4, 5, 6, 7 times. If you want to write that as 3y to the 7th power, then you need to put parentheses around this so that you're showing that you're taking the whole thing, 3 and y to the power of 7. You could also write it as 3 to the power of 7 and y to the power of 7, because technically there's 7 3's and 7 y's. The only way you can't write this is like this, because that only says y to the 7th power, not 3, and you need 7 3's as well, so that one's not okay. And what we're going to do is talk about 5 rules that happen with exponents. The first rule is powers of 0. So anything to the power of 0 equals 1. So it doesn't matter what all is going on in here. As long as it's being taken to the power of 0 on the outside, it equals 1. Now, just be a little careful because sometimes you'll get a tricky problem where this 0 only applies to the x. So this part equals 1, but this 5 doesn't because it doesn't have an exponent of 0. Only the x does. So really, this should be 5 times 1, or 5. And then this last one I made purposefully complicated in looks. If this whole thing has a 0 power, it's just 1. All right, now let's talk about something called the product rule. So the product rule is when you have two variables being multiplied together. The product is that multiplication right there. The next rule is going to be quotient. Quotient means division, so you have to have a fraction like that. And I'm going to write it out in the expanded form to show you why this rule works, but then after that, you can just use the pattern. So if I take this and I write x to the third, here we go. There's x to the third. And then if I write x to the fourth, that's 1, 2, 3, 4. And these two things are being multiplied together. So it doesn't really matter that I did it in two different colors at all because it's all going to be put together. Now I have a total of 7 x's. The question is, what is an easier way of counting that out other than going 1, 2, 3, 4, and so on? Well, we had 3 of them over here, we had 4 of them over here, so together that makes 7. And what we're really doing there is we are going to be adding the exponents. So coming over here, you've got m squared and m to the fifth. That's like saying you have 2 m's here and 5 m's here. So together, how many m's would that be? 7. Just keep in mind that this is an exponent because technically those m's are being multiplied. Then you'll notice that it also has this 3 and the 2 out front. This part is going to be a part that a couple of us get confused over a few times. Those aren't exponents. Those are regular numbers. So we're going to do 3 times 2. Normal style. And 3 times 2 is 6. So we only add exponents. Now let's talk about the quotient rule. The quotient rule is where you have some on top and some on bottom. In this case, I have 5 of them on top and 3 of them on bottom. And whenever you have something on the top and the bottom of a fraction, as long as everything's being multiplied like this, you can cross some of them out in pairs. So like I can cross those two, those two, those two, and then I'm out of ones on the bottom, so I just have 2 left on the top. That would be x squared. I think of these as takeaways. You had 5 on the top, and you could take away 3 of them because there's 3 on the bottom. Well, 5 take away 3 is 2. You might have heard takeaways in like elementary school. What we call that now is subtraction. And then we're going to move over here to the right side and try one using the rule. So we're not going to write it all the way out. Okay? And I'm going to do this one in 3 parts. I've got my regular numbers, my m's, and my n's. So in front, those aren't exponents. So we need to do basically 15 divided by 5, which is 3. Then m cubed and m to the first on the bottom. So if something doesn't have an exponent at all, it gets an exponent of 1 automatically. And if you have 3 on top and you take away this 1 on the bottom, now you only have m squared left. And then I'm going to do the ends. I have 3 on top, I'm taking away 2. Now I only have 1 left. And you can either write that as n to the first power, or you can just write it as n. In which case it will just not have that little 1 right there, like this. Okay, whichever way is fine with me. Okay, so if they're next to each other side by side, they're being multiplied, add the exponents. Only if it's an exponent. If they're being divided like this, that's the quotient rule, and you'll subtract. Moving on down to the power rule. This is when you have a power to a power. That's why it's called the power rule. So you go at x to the third to the squared. So there's two powers back to back. What this means is you would do x to the third, which is, by the way, 3x's being multiplied. And you need to do that twice because it's squared. That means you multiply something by itself so that there's two of them. Now, how many x's do I have? 6. Because I took my 3x's from the inside of the parentheses 2 times. Or I'm even going to change this up and say, what if it was x cubed to the 4th? Then you would have those 3x's 4 times. And you don't have to write this part down if you don't want to. So I've got my 3x's 4 times. Well, these 3 times 4 is going to be 12x's. So you're going to multiply these exponents. Coming over here to the right, I'm going to multiply only my exponents. So 5 and 2 makes 10. Then, what about this 3 in front? Well, remember how it has a default exponent of 1. So 1 times 2 is 2. If you have a number to a power, go ahead and actually do that number to that power. So like 3 squared is 9. Just to make it look a little simpler. And then the last rule is probably the weirdest rule, because negative exponents look a little funky. And the first thing that I'm going to do is use the same rule we used up here when we were dividing. And that is that you could subtract these two exponents. Okay, so you would do 3 minus 8. Well, that's negative 5. So really, we have x to the negative 5th power. But what happens when you have a negative exponent? Well, let's write the expanded form out and see what we can find. So really, this one has 3 x's on the top and 8 of them on the bottom. And I can cross some of them out if I want to. Here, here, and here. And I have 1, 2, 3, 4, 5. But look at where those 5 x's are. They're on the bottom. And if you don't have anything left on the top, you have to leave a 1. You can't just write nothing on the top. So basically what we just found out is x to the negative 5th is the same thing as 1 over x to the 5th. And for this rule, I'm going to go ahead and describe it as flipping. Anytime you have a negative exponent, it needs to move to the other side of the fraction. So looking at this next example, only the x and the z have negative exponents. The 2 and the y don't, so they get to stay right where they are at on the top. But the x has to move down, and the z has to move up. So wherever it's at, it has to move to the other side. Since this one's on the top, it has to move to the bottom. Since the z is already on the bottom, it has to move to the top. So the z is going to go to the top now, and its exponent is no longer negative. Just like over here, when this x was in the bottom, its exponent wasn't negative anymore. And the x is going to go to the bottom, and it's going to have a positive exponent as well. So once you flip it to the other side, now it doesn't have a negative exponent. And the directions will say that you only want to have positive exponents in your answer. So you only want to have positive exponents left. If you have a negative exponent, it just has to move. You don't have to add, subtract, or multiply, you just move it. So it's actually a pretty easy one to do, but it's kind of weird.